Okay, let's have a look at the solutions to homework. In topic 4a, we have already learned how to solve a system of linear equations, right? The most commonly used methods are either substitution or elimination. So let's try to use different methods to solve each of the questions here. First of all, for the first question, we can use elimination method. Which means by subtraction or sum of the two equations, we can eliminate one of the two unknown variables, x or y, right? But before that, sometimes we have to manipulate one or both of the equations first. For example, let's call them equation number 1 and 2. First of all, if you want to eliminate either x or y, so for example, let's eliminate y first. Then we should use equation number 1 multiplied by a constant 2, right? And this gives us 4x minus 6y equals negative 10. And then use equation number 2 multiplied by a constant 3. In this way, we have 15x minus 6y equals 12. In this way, as you can see here, we have negative 6y in both of the two equations, right? Then let's use equation number 4 minus equation number 3, and this will give us, the left side is 11x, and the right side is 12 minus negative 10, which gives us 2, right? Therefore, we have x equals 2. And then let's put 5 back into either equation number 1 or 2, either 1. So for example, let's use the first one. Then we will have 2 times x, which is 2 minus 3y equals negative 5. And from there, you can have 3y equals 4 plus 5, which is 9. Therefore, we have y equals 3, right? And eventually we have a pair of solutions there, which is x equals 2 and y equals 3, right? And of course, you can also use substitution method. So let's have a look at the other method we can use, which is called substitution. Well, in this method, usually you should solve one variable in terms of the other and substitute into the other equation. So for example, we can start from equation number 1, solve x in terms of y, or solve y in terms of x. So for example, let's solve x in terms of y. This means 2x equals 3y minus 5, right? And x equals 3y minus 5 divided by 2, and let's call it equation number 6. And then let's put equation number 6 into the other equation, which is the equation you haven't used yet, which is number 2. And this way we have 5 times 3y minus 5 over 2 minus 2y equals 4, right? Then let's call this equation number 7. Then we could multiply equation number 7 by a constant 2 to both sides. In that way, we will have 5 times 3y minus 5 minus 4y equals 8, right? And this gives us 15y minus 25 minus 4y equals 8, which is further simplified to 11y equals 25 plus 8 gives us 33, right? Therefore, we know y equals 3. Again, let's call this equation number 7. Then you could put equation number 7 back into equation number 6 here in order to solve the value of x, right? So x equals 3y, which means 3 times 3 minus 5 over 2, right? And that's 9 minus 5 over 2, which is 2. and therefore we have the same pair of solution, which is x equals 2 and y equals 3. Now, actually, for this specific question, I think the first method seems much easier, right? Because that does not involve the manipulation of fractions, which is usually time consuming. Okay, have a look at the question here. Let me know if you have any questions, okay? And if no questions, let's proceed to the next one. Again, the method should be the same. First of all, let's reorganize this system of two linear equations. The original system is equivalent to, first of all, 5x minus 6y equals -4. Usually we'll put constant number to the other side of the equation, right? And 3x minus 2y equals -4, right? Okay, then again, we can use either elimination or substitution method. So method 1, elimination. And again, personally, I think elimination method is much easier than substitution. So in order to eliminate one of the variables, we should multiply either first equation or the second equation with some constant. And actually, because the least common multiple of 6 and 2 is 6, so we can use equation number 2 times a 3 in order to eliminate y, right? So this gives us 9x minus 6x equals the right side gives us -12, right? And then let's call this equation number 3. And then you can use equation number 3 minus equation number 1. Then the left side gives us -6y cancels with each other, right? And 9x minus 5x gives us 4x equals, the right side is -12 minus -4, which is -8. And immediately you can solve x equals -2, right? And then put equation number 4 back into either 1 or 2. For example, I think the second one is easier. And then you have 3 times -2 minus 2y equals -4, right? And simplify this will give you 2y equals -6 plus 4, which equals -2. And we know y must equal -1, right? And therefore we have found a pair of solution which is x equals -2 and y equals -1. Did you get it? And of course you can verify result by putting the pair of solution into the original equation to verify if the pair of solution can satisfy both of the two equations. Again, you could also use substitution method. Okay, which means we could start from either equation number 1 or 2 to solve one variable in terms of the other. For example, we can start from the second one, which means 2y equals 3x plus 4, right? And solve y in terms of x gives us y equals 3x plus 4 over 2, right? And let's call this number 5 because 1, 2, 3, 4 has already been used. Then put equation number 5 into the other equation which you have not used yet, which is equation number 1 in this case. And we have 5x minus 6y, which is 6 times 3x plus 4 over 2. equals negative 4, right? And therefore, as you can see here, basically you have an equation and only one variable there. You somehow eliminate the variable y, right? So we can simplify this to 5x minus 3 times 3x plus 4, then plus 4 equals 0, right? And this gives us 5x minus 9x minus 12 plus 4 equals 0, which means 4x equals negative 8. And we can solve x is negative 2, right? And let's call this equation number 6. Then put equation number 6 back into equation number 5. Then you will have y equals 3 times x, which is negative 2, plus 4 over 2, which gives us negative 1, right? And of course, as you can see here, we have the same pair of solution, which is x equals negative 1, x equals negative 2, and y equals negative 1, right? Again, have a look at the solution here, particularly if you have not submit your solution to me, okay? Have a look at the solution and let me know if you have any questions. Alright, then if no questions, let's have a look at the next one. Question number 3. Again, a system contains two linear equations, right? So let's call them equation number 1 and 2. And this time, let's use first elimination method. So the best way to eliminate one of the variables is to use equation number 2 times the constant to either side. Then we will have 4x plus 6y equals negative 10, right? And then we can use number 3 minus number 4. And then we can cancel a 4x here. 6y minus 7y gives us 13y, right? On the other side, we have negative 10 minus 13, which is negative 23, right? Therefore, y equals negative 23 over 13. You see that? And then you can put, sorry, this is not number 4, this should be number 1. Then put number 4 back into equation number 2, and we have 2x plus 3 times negative 23 over 13 equals negative 5. And we can multiply a 13 to both sides. This will give us 26x minus 69 equals negative 65. Therefore, 26x should equal 69 minus 65, which is 4. And then we can solve x is 4 over 26, which is 2 over 13, right? And we can find a pair of solutions here. X equals 2 over 13 and y equals negative 23 over 13, right? And again, of course, you can also use substitution method. So first of all, we can start from equation number 2. Solve x in terms of y, or vice versa. So solve x in terms of y gives us x equals negative 3y minus 5 over 2, right? And let's call this number 5. Then put equation number 5 into the other equation, which you have not used yet. This will give you 4 times negative 3y, sorry, minus 5 over 2, then minus 7y, right, equals 13. So simplify this equation will give us negative 6y minus 10, then minus 7y equals 13, which can be further simplified to 13y equals negative 23. Therefore, y equals negative 23 over 13, right? Let's call this number 6. Then put number 6 back into equation number 5. This will give us x equals negative 3 times negative 23 over 13 minus 5 divided by 2. And eventually, that can be simplified to 2 over 13, right? Therefore, we have found a pair of solution. X is 2 over 13 and y equals negative 23 over 13. For this particular question, I think both of the two methods are not very complex. Okay, have a look at the solution here. Any questions, just let me know, okay? All right, if no questions, let's have a look at the next one. Again, another system of two linear equations. And apparently the elimination method is much easier, right? Because if you add equation number 1 to equation number 2, then immediately you can cancel a y there, right? So let's have a look at the first method, which is elimination. You can use equation number 1, add it to equation number 2. This will give us, the left side is just 5x, right? And the right side is 20. So immediately you can solve x is 4. Then you can put equation number 3 back into either 1 or 2. So suppose let's put it back in number 2. Then we will get 2 by 4 plus 7y equals 6, which means 7y equals 6 minus 8, which is negative 2, right? And of course, y should equal negative 2 over 7. And then the solution is x equals 4 and y equals negative 2 over 7. So when you finish the solution of a system of two linear equations, it's better to write your solution in this way. Or you could also write it in this way. You could write it as the pair of xy equals 4, negative 2 over 7. Either way is okay. Okay, this is a conventional way we express the solutions to a system of two linear equations. And of course, you can also use substitution method. And in this way, we should again solve one variable in terms of the other. So let's start from the second one. I think it's much easier. Solve x in terms of y gives us x equals 6 minus 7y over 2. Then let's call this equation number 4. Then put equation number 4 into the other equation, which you haven't used yet. This will give us 3y, which is 3 times 6 minus 7y over 2. Minus 7y equals 14. And then simplify that equation by multiplying both sides using number 2. This will give us 3 times 6 minus 7y, and minus 14y equals 28. And then simplify that to 18 minus 21y minus 14y equals 28. And this gives us 35y equals negative 10, right? And that means y equals negative 2 over 7. And let's call this equation number 5. Then put 5 back into 4. This will give you x equals 6 minus 7 times negative 2 over 7. Divided by 2. And this means x equals 4, right? And of course, the final solution is x equals 4 and y equals negative 2 over 7. Of course, you can also write it in this way. Either way will do, okay? Alright, have a look at the solution here. Any questions, just let me know, okay? Alright, then let's consider the next one. Okay, so from now on, I'm gonna just choose the better way to solve them, okay? I'm not gonna write both of the two methods here. Just choose a appropriate way to solve this system. So let's label them with number 1 and number 2. And again, I think elimination method works better, right? So we could use equation number 1 times a constant 4 to both sides. This will give us 32x, then plus 4y equals the right side is 52, right? And call this equation number 3. Then you can use equation number 3 minus equation number 2. Then the left side will give you 29x. And the right 4y cancels with 4y, right? And the right side is 52 minus 6, which is 58. And then we can see x is just 58 over 29, which is 2, right? And if you solve x is 2, then we can put this result back into equation number 1 or 2. But I think 1 is much easier, right? So this means 8 times x, which is 2, plus y equals 13. And this can be simplified to y equals 13 minus 16, which is negative 3, right? And of course, the final solution is x is 2 and y is negative 3. Can you see that? And again, of course, you can try to solve this system using substitution method. which is not that difficult, right? You can start from equation number 1. Solve y in terms of x, gives you y equals 13 minus 8x. Then put this result into the other equation, right? Okay, you can try this by yourself. I'll give you 1 minute to try this by yourself, okay? Try using the other method to solve it. Alright, if you have finished, let's have a look at the next one. Okay, the next one involves the constant, which are fractions. So usually we don't like fractions, right? Because it will complicate the problem. So if you don't like that, you can multiply the common denominator to change the coefficient to a integer number, right? This does not change the solution set. So we have okay, let's write this directly. So the original system is equivalent to, first of all, if we multiply a 7 to both sides of the first equation, this does not change the solution set, right? Because it's the equivalent transformation. So this will give us 2x minus 3y equals 7, right? And we can then multiply a 5 to both sides of the second equation. Again, this does not change the solution set because this is again also a equivalent transformation, which gives us negative 2x then plus 6y equals 5, right? Then let's call these two equations number 2 and number 1 respectively. Then we can use equation number 1, add it to equation number 2, and this will cancel the x, which will only leave us 3y equals 12. And of course you can solve y equals 4, right? And put y equals 4 back into equation number 1, for example, then you can solve x. So 2x minus 3 times y, which is 4 in this case, equals 7. And this gives us 2x equals 7 plus 12, which is 19. And of course, x should equal 19 over 2, right? Did you get it? Therefore, the solution is x equals 19 over 2, and of course y equals 4. Okay, have a look at the solution here. Any questions, just let me know, okay? All right, next one, number 7. Again, if you don't like decimal coefficients, you can multiply both sides using the same number to eliminate any decimal numbers. Change the coefficients to integers. So this is equivalent to, for the first equation, we can multiply both sides using number 5, right? Times multiply a number 5 to both sides. Again, this is equivalent transformation, does not change the solution set, but only will change the coefficients from decimal numbers to integers, which gives us negative 6x plus 3y equals negative 6, right? And of course, this can be further simplified by dividing both sides using 3. So that's negative 2x plus y equals negative 3. For the second one, we can multiply both sides using number 5 again. This will give us 2x plus y equals negative 1, right? Sorry, there is a typo. This should be negative 2, not negative 3. Then we can use equation number 1, add it to equation number 2 to eliminate x. So these two items cancels with each other. So 2y equals negative 3, right? And of course we can solve y immediately, which is negative 3 over 2. Then put y equals negative 3 over 2 back into, for example, equation number 2. This will give us 2x minus plus y is minus 3 over 2 equals negative 1. And we have 2x equals 1 over 2, which gives us x equals 1 over 4, right? Therefore, the final solution is x equals 1 over 4 and y equals negative 3 over 2, right? Okay, again, have a look at the solution here. Any questions, just let me know. Alright, if no questions, let's have a look at the next one. For question 8, it seems that we don't have a system of linear equations here, but the method we use to solve a system of linear equations should also work here, right? The key is to eliminate one of the two variables. If you only have one variable and one equation, it's very easy to solve, right? So the takeaway of number 8 is sometimes, although we don't have a system of two linear equations, but the substitution method or the elimination method can also work to solve a system like this, because once you eliminate one of the variables, it's very easy to solve a variable from one equation, right? So the key is to reduce the number of unknown variables. So the principle is true for the next question as well. Although we have a system of 3 linear equations, the nature should be the same. You should eliminate or reduce the number of unknown variables from 3, then to 2, then to only 1, and solve that one variable. Then that will help you to solve the other 2, right? So we haven't talked about much about a system of more than 2 linear equations, so we'll leave number 9 at the end of this class, okay? So let's have a look at number 10 first, which is a word problem. For a word problem, you need to model that problem using mathematical language first. In this case, we should define the variables first. Usually we'll use the capital letter of the word related to define the variables. For example, we could use letter E, B, Tweedledee, weight, and let the letter M be Tweedledum's weight, because E is from here, M is from here. This is very easy for us to remember the meaning of each variable, right? And for any letter that is not in the question, you need to clearly define the meaning of that variable. So from Tweedledum's statement, we have this relationship: E plus 2M should equal 361, right? From Tweedledee's statement, we have another equation, which is 2E plus M equals 362, right? Then our task is to solve E plus M, because the question asks you how much do Tweedledum and Tweedledee weigh together. So our task is to find E plus M. So you do not necessarily find E and M first. As long as you can find E plus M, you can conclude the question, right? Of course, there are 2 equations and 2 variables. You could solve E and M first, but it's not in that way necessarily. So because the question only asks find E plus M, right? So our task is to find E plus M. Then we could use equation number 1 plus equation number 2. This will give us 3E plus 3M, which actually is 3 times E plus M, right? On the left side. The right side is simply 361 plus 362. The advantage of doing this is you do not have to solve E and M. Then you immediately know E plus M is 7, 2, 3 over 3, right? Which is 2, 4, 1, right? The unit is pounds. Do not forget unit. And therefore, you should make your final statement. They weigh 2, 4, 7 pounds together. Okay, do not just say E is some number and M is some number, because the question does not ask you this, right? This is some steps in between. If the question asks you how much they weigh together, you must answer the question in your final statement here. Okay, do not forget this. All right, have a look at the solution here. Any questions, just let me know, okay? Okay, next question, number 11. My parents started a small farm after they retired. On their farm, they have chickens and pigs. In total, there are 40 animal eggs among the chickens and the pigs, and there are 16 animal heads. How many chickens do my parents have? Okay, so what we don't know here is the number of chickens and pigs, right? And the question really asks you to find the number of chickens. So we could use letter A, denote, or B, the number of chickens, right? Because C is from the first letter of chickens here. And of course, let P denote the number of pigs. And according to the given information, we have first each chick has 2 legs, so we have 2C plus 4 legs per pig, so 4P, right? This is the total number of legs, which equals 40. And total number of heads is C plus P. Suppose each of the chickens and pigs is normal chick and pig, so each of them has 1 head only, right? So C plus P gives you the total number of heads, which is 16. Again, 2 equations, 2 unknown variables. We could solve C and P respectively, right? First of all, we can simplify the first equation to C plus 2P equals 20 and C plus P equals 16, right? Also note that the question only asks us to find the number of chickens. So you actually don't have to solve P, right? But let's solve them both here. So we could use number 1 minus number 2. This will give you P equals 4, right? Of course, then you can insert P equals 4 into equation number 2, and this will give you C equals 12, right? And again, you should make the final conclusion. So there are 12 chickens in the farm, right? Did you get it? Okay, any questions here? Alright, if not, let's see the next one. Sum of Eric's Bob's weights is 9 times the difference of their weights. The positive difference of their weight is also 240 pounds less than the sum. If Eric weighs less than Bob, find Bob's weight. Okay, we have 2 ways to find, right? So we could let E be Eric's weight. And be careful with the unit. Unit is pound because sometimes you need to convert units. We could also let B be Bob's weight. Again, this is in pounds. Then according to the given information, we have the sum of E plus B equals 9 times the difference between B and E, right? Because that's Eric weight less than Bob, so B is larger than E. And B minus E equals E plus B minus 240, right? So first of all, simplify this system, which gives us first 10E equals 10E minus 8B equals 0, and 2E minus 24 okay, second one just gives us 2E equals 240, right? And this is equivalent to say, first of all, 5e minus 4b is 0. And the second one directly gives you e, right? E is 120. Therefore, we could just insert number 2 into equation number 1, which gives us 5 times 120 minus 4b equals 0, and 4b equals 600, and b is 150, right? Therefore, we know the solution is e equals 120 and b equals 150. And we can make the conclusion. Bob's weight is B, right? 150 pounds. Do not forget to answer the question. All right, have a look at the question here. Any questions, just let me know, okay? All right, if no questions, let's have a look at the next one. So here we have two unknown variables, which is weight per green ball and weight per red ball, right? So we could let G be the weight per green ball, and here's unit is pounds, and then let R be the weight per red ball, and the unit is pounds as well. Then according to the given information, we have the following relationship. So first of all, 5G plus 2R should equal 10, right? Because it says 5 green balls and 2 red balls together weigh 10 pounds. And also G plus 4R should equal 7, according to the second sentence, right? 1 green ball and 4 red balls together weigh 7 pounds. And really ask you to find the weight of 8 red and 8 green balls together. So you need to find 8 G plus 8 R, right? Again, not necessarily solve G and R, but we need to find 8G plus 8R equals which pounds. So let's observe the system. In order to find 8G plus 8R, or 8 times G plus R, we could simply add this equation together. This will generate a equation which is 6G plus 6R equals 17, right? And of course we know then 6G plus R equals 17. And this gives us G plus R equals 17 over 6. And remember, we want to find 8G plus R. That means we can multiply both sides using 8. So 8 times G plus R equals 17 over 6 times 8, which can be simplified to 68 over 3, right? Therefore, we know the weight of 8 red and 8 green balls is 68 over 3 pounds, right? Did you get it? Any questions? Okay, if not, let's have a look at the next one. Question number 14. At a certain time, Janice notices that her digital watch reads A minutes after 2 o'clock. 15 minutes later, it reads B minutes after 3 o'clock. She's amused to note that A is 6 times B. What time was it? When she looked at her watch for the second time. So we have two unknown variables, A and B, right? And according to the given information, we can establish a connection between the two variables. First of all, we know that 60 plus B minus A equals 15, right? You get it? Because after 3 o'clock, it's actually 60 minutes past 2 o'clock, right? 60 minutes plus B minutes, then minus A minutes after 2 o'clock gives you 15 minutes later, right? This is according to the given information. And of course, there's another relationship. A is 6 times B, right? So the best way to solve this system is to use substitution. We can substitute A using 6B, right? Which means put equation number 2 into equation number 1. Then this gives us 60. Well, of course, you can actually simplify this equation first, because the first equation is not simplified yet. So first equation gives us B minus A equals negative 45, or usually we don't like negative numbers, so you can put constant to the left side, which means A minus B equals positive 45. Then A equals 6B, right? Then you can put equation number 2 into equation number 1. And of course, this will give you 6B minus B is 45, and 5B is 45, right? And you can easily see that B is just 9. And if B is 9, we can put B is 9 back into equation number 2. This gives us A is 6 times B, which is 9, and this gives us A is 45, right? Therefore, we have the solution. A is 45 and B is 9. And do not forget to answer the question which is asked here. What time was it when she looked at her watch for the second time? For the second time, it's actually B minutes after 3 o'clock. So we could say the second time she looked at her watch is 3:09, right? Yeah, 6 by 9 is 54, but we have 5b equals 45 here, right? Oh, sorry. Yeah, I see your point. Here should be 54. Sorry about that. It's a typo. 6 by 9 is 54. Okay. Thanks for the correction. But here we only need B, right? Okay, any questions? Alright, if not, let's see the next one. area of a square equals the square of the length of the side of the square. The perimeter of a square equals sum of the length of all four sides. The sum of the square of two squares is 65, while the difference in their area is 33. Find the sum of their perimeters. So we can let the side of one square be x, right? And then let the side of the other square be y. Then according to the given information, we have first of all x squared plus y squared equals 65, right? And let's suppose this is a larger one. Then we have the difference equals 33, right? Two equations, two unknown variables, we should be able to find both of the two variables. For example, we could use equation number 1 plus equation number 2. And this gives us 2y squared equals 98. And of course, y squared equals 49. And also note that if the side of one square is x, x must be greater than 0, right? Because x cannot be 0 or negative number. Otherwise, does not make any sense for a negative side of square, right? Of course, here y is also larger than 0. It could not be negative number, and it could not be a 0 because it has a area, so it could not be 0 either, right? So y must be positive. This gives us y can only be positive 7, right? And if y is 7, we can put back into equation number 2. This will give us 49 minus x squared equals 33, which means x squared equals 16. Again, because x is greater than 0, we have only one solution. X must be positive 4, right? And therefore, we have the only solution is x equals 4 and y equals 7. And we want to find sum of their parameter, which means we need to find 4x plus 4y, right? Which equals 4 of x plus y, which is 4 times 11, which is 44, right? So you should conclude this question by answering the sum of their parameters is 44, right? Any questions? Okay. If no questions, let's get back to question number 9. We haven't solved this yet, right? Okay, question number 9 is a system of 3 linear equations, and the method should be the same to solving a system of 2 linear equations. We could use either elimination or substitution method. So first, let's have a look at the first method here, which is substitution. And the key is to eliminate or reduce the number of variables. So, okay, first of all, let's simplify the first equation a little bit. First equation can be simplified by dividing both sides using 3, right? So that's x minus 3z equals 11. Second one, we could just leave it there. Third one, we could not further simplify that, so just copy them. Call them number 1, 2, 3 respectively. This first one is much easier because it does not have y, right? So from the first equation, we can solve x in terms of z. which means x equals 11 plus 3z, right? Let's call this equation number 4. So then you can actually put equation number 4 into equation number 2 and 3. In this way, we can eliminate x there, right? So if we put 4 into 2, we will get 7x, which is 7 times 11 plus 3z. Then minus 4y minus z equals negative 15. And simplify this to 21z minus z is 20z, right? Then minus 4y equals negative 15 minus 77, right? So that is negative 92, right? And organize this a little bit. That's 2y minus 10. Oh, actually, we can divide both sides using a 4. So this will give us 5, 1, negative 2, 3, right? And that gives us y minus 5z equals 23, right? Okay, you can just leave it there. Then put equation number 4 into equation number 3. And this will also eliminate x there. So 4 of x, which is 4 times 11 plus 3z plus 6y plus 5z equals negative 6. And simplify this a little bit, which gives us 44 plus 12z. 12z plus 5z is 17z, right? And plus 6y equals negative 6, which can be simplified to 6y plus 17z equals negative 50, right? So let's call this number 5 and number 6. Then we have a system of two linear equations and two unknown variables y and z. You can just solve y and z there, right? That means we have converted this original question to a new question of a system of just two linear equations with two unknown variables, which we already have the methods to solve, right? Again, you could use either substitution or elimination method, right? And okay, from number 5, we can have y equals 23 plus 5z, right? Let's go, this is number 7. Then put number 7 into number 6. This will give us 6y is 6 times 23 plus 5z, right? So again, we eliminate the variable y or reduce the number of unknown variables to only one, which is z here, right? Plus 17z equals 50. Simplify this equation, gives us 138 plus 30z plus 17z equals negative 50, and we have 47z equals negative 188, right? And we can solve z is negative 188 divided by 47. Do we have an integer here? We could put a 4, so that's negative 4, right? And let's call this equation number 8. Then you can actually put equation number 8 back into the equation here. Here, 7, right? Put 8 into 7 will help us to solve y equals 23 plus 5 times negative 4, which is 3, right? So we have another result for y. And if you know x and if you know y and z, then it's very easy to solve x, right? So we could put equation number 8 back into here, equation number 4. And this will give us x equals 11 plus 3 times z, which is -4. And we have -1, right? You follow me? Therefore, the final solution is x equals -1, y equals 3, and z equals -4. You get it? And this is our final solution. Okay, have a look at the solution here. Any questions, just let me know, okay? And of course, you can also use elimination method. So let's try to use elimination method to solve that. So the original, first of all, the original equation can be simplified to an equation like this, right? And then let's organize this equation a little bit. So first equation is x plus 1x plus 0y minus 3z equals 11, right? And then 7x minus 4y minus z equals -15. And then 4x plus 6y plus 5z equals -6, right? And let's call this 4, 5, 6. And next we could use equation number 4 times -4. Then add it to, sorry, we could use equation number 4 times -7, add it to equation number 5 to eliminate x here, right? So this will give us 0, 0x, right? And minus 4y. Then plus 20z equals, so -77 minus 15, right? -92. And then equation number 4 times -4 added to equation number 6 will give us 0x plus 6y, right? And -4 times 3, -3 is 12, so plus 17z equals -44 minus 6, which is -50, right? Okay, so let's call this 7 and 8. Also note that equation number 7 can be simplified to 0x minus y plus 5z equals -23, right? So this is equation number 9. Therefore, we have actually a new equation, new system, which is equivalent to the original one, which is 1x plus 0y minus 3z equals 11, and then negative x minus y or 1y plus 5z equals negative 23, and then negative x plus 6y plus 17z equals negative 50, right? And then from there, actually, we can further eliminate y, right? So let's call this number 10 and number 11. So we can just keep the first one unchanged. Just leave it there. And then use number 10 times 6, add it to number 11. So this does not change the second equation, but the third one changes to 0x, then plus 0y, negative 188, right? And again, this can be further simplified to 1x plus 0y minus 3z equals 11. 0x minus 1y plus 5z equals negative 23. And 0x plus 0y plus z equals negative 4, right? And use number 12 times 3 added to equation number 1. This will give us 1x plus 0y plus 0z equals negative 1, and 0x minus 1y plus 5z equals negative 23, and 0x plus 0y plus z equals negative 4. And of course, we can multiply the second one, both sides, using negative 1. So this will change the sign here to positive 1, right? Then negative 5z, then positive 23. And then using 5 times the third one added to the second one, this will give us 1x plus 0y plus 0z equals negative 1, 0x plus 1y plus 0z equals 3, and 0x plus 0y plus z equals negative 4, right? And here, actually, we have the solution, which gives us z equals negative 4, y equals 3, and x equals negative 1. Can you see that? And actually, as you can see here, we only need to manipulate the coefficients rather than the whole equation. So there is another method, which is called the matrix method, which you can use to solve this equation. The only thing we need to do is to manipulate all of the coefficients. And we'll talk about the matrix method in our next lesson, okay? So eventually, this is a matrix containing the original coefficients, and use some equivalent transformation. Finally, we landed here. This is a converted matrix, and each step of the conversion is equivalent, which means it does not change the solution set. But eventually, when you have a matrix like this, you can directly read the solution, which is z equals negative 4, y equals 3, and x equals negative 1. We'll talk about the matrix method in our next lesson. Sounds good? This method is quite useful when solving an equation, a system that contains more than two linear equations. Okay,